11.3 Applying Properties of Chords. The chord bisector theorem. The perpendicular bisector of a chord passes through the center of a circle, or a diameter that is perpendicular to a chord bisects the chord. So on a diagram, it'll look something like this. So we're talking about a perpendicular bisector of a chord, and it's got to pass through the center. So here's a chord, and we are eyeballing this. So this is AB. And then if we get the perpendicular bisector, it's going to pass through the center here. So this is a perpendicular bisector, and it also creates congruent arcs up here as well. So example number 1, find arc AB and BC. Well, if this is a perpendicular, then it's a perpendicular bisector, so that means A to this middle point is congruent to this middle point to C. And that also means that these two arcs are congruent, so we can say 3x minus 35 equals 2x plus 1, minus 2x, x minus 35 equals 1, x equals 36. And then we can plug it in and figure out what they are. So 3 times 36 minus 35, which is going to be 108 minus 35, which is 73. And then 2 times 35 plus 1, which is going to be 72 plus 1, which is also 73 degrees. So they do match, they are congruent. Important properties of circles. In a circle, congruent chords have congruent corresponding arcs. So if we say that AB is congruent to CD, that also means that arc AB is congruent to arc CD. So then conversely, congruent arcs have congruent corresponding chords. Write 2 geometric implications from the figure right. So we know for sure that AB is congruent to CD. Then that means that arc AB is equal to arc CD. Or congruent, you could write it as congruent, but their measures are also equal. All right, let's do some checking key concepts. Find each length or measure. We'd like to know the measure of BC, arc BC, and this is point B. It's not labeled on there. So if we'd like to know BC, it is a perpendicular that's through the center, so it's a perpendicular bisector, which means that if this is 49 degrees, then this arc is also 49 degrees. We'd like to know the length of AD, so that's from here. So if this is a perpendicular bisector, that length is 6, so this length must also be 6. Then we'd like to know the major arc CFA, so C to F to A. So if this is 49 and 49, that's 98, and then the rest of it is a chunk of 360. So 360 minus 98 gives us 262 degrees. And finally, the last length that we'd like to know is BF. So we'd like to know how long the diameter is. Well, you have to look at the diagram and make sure that you're picking a radius. This length of 6 is not a radius, but this length of 8 from E to A is a radius. So if this length is 8 and this length is 8, then BF is 8 times 2, or 16. Find the value of each variable. So if these are congruent chords, then their arcs are also congruent. So we can say 80 is equal to 3x plus 20 minus 20, 3x equals 60, and x equals 20. All right, we'd like to find the value of t. I can see that it's congruent to this length right here, which would also be t. I also know that this chord is 24, but I can see that it's a perpendicular that goes to the center, so that means that this would be 12, and this would also be 12. And now right here, we've got a right triangle where I know one leg is 12, one leg is t, and the hypotenuse is 13. So we can use the Pythagorean theorem to find that third side. So t squared plus 12 squared equals 13 squared. Some of you may recognize that that's a Pythagorean triple. I can tell that it's going to be 5, 12, 13. But that's going to be 169 minus 144, which is 25. And t equals 5. All right, number 7, x and y. I know that x and y are equal, so if we calculate just one of those, we know both of them. Right now, I can see that this length is 9, and this length here from that intersection to here is 8. But we're trying to calculate one of these lengths. Again, I know that they're equal, but I'm not sure that they're equal to this. So one of the tricks is saying, how long is the radius? I can see that the radius is a 9 plus 8, or 17. And what we can do is I can draw in an additional right triangle here. And I know that this hypotenuse is 17 because it's the same length as the radius right there. So now I've got an 8 and an x and a 17 for a Pythagorean theorem problem. So we've got x squared plus 8 squared equals 17 squared. 17 squared minus 8 squared is 225. And the square root of 225 is 15. So x is congruent equal to y, or congruent to y, which is also equal to 15. Thank you.